welcome to my channel. In this video, we will learn how to solve a truss using the method of joints. This is the problem we are going to solve. We have to determine the loads in each of the members of the truss using the method of joints. We labeled the joints with letters, and we have to calculate the internal forces in these 9 members. First, we have to calculate the support reactions. We should draw the free body diagram for the whole structure, considering it as a rigid body. So as you see, this is the whole structure, the external loads, the dimensions, and the support reactions. We should use the static equilibrium's equations. The sum of the forces at the x direction equals to 0, the sum of the forces at the y direction equals to 0, and the sum of the moment about any point equals to 0, considering that the force that goes counterclockwise causes a positive moment. In order to find the support reactions, we will write the sum of the moment about point A equals to 0. So we have minus 5 multiplied by 4, minus 5 multiplied by 6, and YB multiplied by 8 equals to 0. Using the calculator, we can find that YB equals to 6.25, and it's in the positive direction of Y. To find YA, we will write the sum of the forces at the Y direction equals to 0. So we have YA plus YB minus 5 equals to 0. Easily we can find that YA equals to minus 1.25. This means that YA equals to 1.25, and the direction assumed is wrong, and it's in the negative direction of Y. So when you get a negative answer, then the direction assumed for the support reaction is wrong, and the right one is opposite to the assumption. To find XA, we will write the sum of the forces at the x direction equals to 0. The only forces acting at the x direction is this 5, so XA equals to 5. Using trigonometry, we will calculate these angles, alpha, beta, and gamma, and these are the answers. The method of joints is usually the easiest way to analyze a truss. It analyzes the forces in each member by breaking down the truss and calculate the forces in each individual joint. As you see, here is the free body diagram for each joint, considering the axial forces, the external forces, and the support reactions. Now we should start with the joint that has only 2 unknowns. As you see, both A and B are a good choice. We cannot start with joint C, F, D, or E because they all have more than 2 unknowns. So we are going to start with joint A. This is the free body diagram for joint A. This is the internal force in the member AC, and this is the internal force in the member AE. So we label the forces FAC, FAE, and so on. We will use cosine and sine to determine the x and y components of a force. Every member is assumed to be in tension. A positive answer indicates that the member is in tension, and a negative answer indicates that the number is in compression. In other words, we will assume the direction of a force. If we get a positive answer, then our assumption is right, and if we get a negative answer, then our assumption is wrong. So we will write the sum of the forces at the x direction equals to 0, so we have XA, the force, and FAC cosine alpha, and it's the x component of the force AC. This means minus 5 plus FAC plus FAC cosine 63.43 equals to 0. We will label this equation with number 1. The sum of the forces at the y direction equals to 0. So we have YA, and we wrote minus because it's in the negative direction of y, plus the force at the AC member, or FAC, sine alpha, and it's the y component of the force AC. By calculating this equation, we will have the force at the AC equals to 1.4, and we have a positive value, then the assumption is right, so the member is in tension. Going back to equation number 1, we find that the force AE equals to minus 4.4, and minus means that the assumption is wrong and the right direction is opposite of the assumption, so the force is in compression. We will go now to joint C and we will repeat the static equations. These are x and y coordinates. This is the free body diagram of joint C. The internal forces at the members are labeled FCF, FCE, and FCA. The sum of the forces at the x direction equals to 0. We have the external load, 5 kN, FCF minus FCA cosine alpha, and this is the x component of the force CA, plus FCE cosine gamma, and it's the x component of force FCE. We will label this equation with number 2. The sum of the forces at the y direction equals to 0. The forces, so we have minus FCA sine alpha minus FCE sine gamma. Calculating this equation, we can see that FCE equals to minus 1.4, so the direction assumed of FCE is wrong, and this is the right direction. Going back to equation number 2, we can find that the force CF equals to 3.8, and the member is also in compression. Now we can go to joint F because it has now just 2 unknowns. This is the free body diagram for joint F. It has no external loads. There is a rule here, says that if a joint from a truss has 3 members and there is no external loads or support reactions at this joint and 2 of those members are collinear, then the third member is a zero force member. So according to this rule, the force at the member FA is a zero force. So we can write the sum of the forces at the x direction equals to 0. So we have FD and FCF. We can find that the force at the member FD equals to 1.4. Now we can go to joint E. We have the magnitude and the direction of both the force at the EA member and the force at the EC member. This is the free body diagram for joint E. The sum of the forces at the x direction equals to 0. We have FEB minus FEA, and the x component of the force EC equals to FEC cosine alpha, and the x component of the force ED equals to FED cosine alpha. The sum of the forces at the y direction equals to 0. We have the y component of both the force ED and the force EC. Solving this equation, we can find that the force ED equals to minus 1.4, then the direction assumed is wrong and the member is in compression. Going back to this equation, we can find that the force EB equals to 3.1. Finally, we draw the free body diagram for joint B. This is the free body diagram for joint B. The only unknown is force BD. The sum of the forces at the x direction equals to 0. So we have the x component of force BD, and it equals minus FBD cosine alpha, and we have also minus FBE. Solving this equation, we can find that force BD equals to 0.7 kilonewton, and the member is in compression. Thank you for watching. Please subscribe to my channel, and if you find this useful, give it a like.